Hey Geometry 2 students, Ms. Craft here. Today we're going to go over lesson 12.1, which is the triangle proportionality theorem. I left lots of examples blank so that you could practice because it's literally just the same thing over and over and over again. Our vocab words here are just the theorems. So if you, instead of making you or having you or me writing in the boxes, I just told you what they are. The triangle proportionality theorem says that if a line is parallel to one side of the triangle, and it goes through the other two sides, then it divides the sides proportionally. Okay, not necessarily congruent, but proportionally. The converse of the triangle proportionality theorem is just switching those if-then statements. So if a line divides two sides, in a triangle proportionally, then it's parallel to the third side. So just, drawing it out, if the lines that you're given are parallel, then you can state that the sides, the ratios of the sides, are equal. Okay? If you know that the ratios of the sides are equal, which I didn't really know how to draw that out, then you can say that the segments are parallel. So that's what you're looking for here. Identifying which one you're using. If you're given sides and no parallel lines, you're trying to prove them parallel by proving that the ratios are equal. Okay, so applying these theorems. The first one here, I have parallel lines, so I can say that the ratios between the sides are equal or congruent, or however you would like to say that. So I have 2 over 7 equal to 3 over x. I'm solving for x here, so I'm going to multiply each side by x. I get 2x over 7 equals 3. Multiply each side by 7 because you need to undo each fraction. Remember that a fraction bar is just division. The inverse of division is multiplication, so you multiply by a denominator to undo that. I'm left with 2x equals 21, and yay, we get a fraction. Again, please make sure that you are leaving all of your answers as improper fractions, as that would be my expectation. So x equals 21 over 2. The next example is not necessarily the triangle proportionality theorem, but you will see figures like this a lot where it's basically a bisector. It's called a midsegment of a triangle. We will get to that. But the segments on each side are congruent. Therefore, the ratios between them would be proportional. But the easiest way to solve this is just to set them equal to each other rather than setting up a proportionality statement. Okay, so the first one that I did, I solved for y because it was a fraction, and I usually like to do those first. So I have y over 2 plus 11 would be equal to 5y minus 7. Again, those tick marks tell me they're congruent, so that means that the values are equal. I chose, because very few people like to deal with fractions, to eliminate my fraction to start. The way that I do that is I multiply by my least common denominator. So I'm going to multiply everything in this equation by 2 so that I get rid of 2 in my denominator. When I multiply 2 times y over 2, I'm left with just y, and then everything else gets multiplied. So y plus 22 equals 10y minus 14. Then I move my variables to the left, my constants to the right, and I get negative 9y equals negative 36. And then I divided each side by negative 9, leaving me with y equals 4. Okay, then solving for x is setting 3x plus 12 equal to 11x. So this time I moved my variables to the right side just because it left me with positive numbers. And I got 12 equals 8x. And then I divided each side by 8 and reduced my fraction. 12 over 8 is x equals 3 over 2. Again, leaving that as an improper fraction, and those would be my answers. The last example for this lesson is finding a value of x that makes a segment parallel to another segment, and this would be using the converse of the proportionality theorem because you're trying to prove the lines parallel given side lengths. But you do literally exactly the same thing, so there's not much of a difference here. I did 20 over 3x has to be equal to 25 over 57. So I started by multiplying each side by 3x. Oh, yeah, okay, sorry. And then I reduced 3 and 57 before I multiplied. Sorry, I was trying to figure out why I didn't have 75 there. Reducing is generally what I do first. Don't know why I didn't identify that, so that my numbers are smaller and it's easier to do math with. So I'm left with 20 equals 25x over 19, because this reduced to 1 and 19. And then I multiplied each side by 19 to eliminate the fraction on the right. And 19 times 20 gives me 380. And then I divided each side by 25, so 380 over 25 reduces to 76 over 5 because each can be reduced by 5. Again, please do not turn anything into a decimal unless I specifically state that. But those are your three possibilities for using the triangle proportionality theorem and the converse of the triangle proportionality theorem. There are 6 examples below if you wanted to try any of those. They are literally the same type of question over and over and over again. Okay, so that's all I have for you for lesson 12.1. If you have any questions, please message me through Canvas. Thank you.